Hello, and welcome to the SAS Global Forum Virtual Conference for 2020. My name is Glenn Clingroth, and I am the Development Manager for SAS Model Manager. And today I will be discussing how to integrate open source models into your model lifecycle with the help of SAS Model Manager. The model lifecycle, as seen in the diagram on this slide, covers data exploration and modeling, deploying models into production, monitoring the model performance, and ultimately training new models and restarting the process. SAS Model Manager is a key component in this process for models built in SAS. But in the last few years, open source models built in languages such as Python and R have become very popular with data scientists. There are several high-quality packages such as scikit-learn and XGBoost that are widely used in many organizations. A challenge for many organizations is that the data scientists are very good at creating models, sometimes tens and hundreds of models for a single problem. The problem then becomes keeping track of the model code and all of the analysis that is associated with the model. Model Manager was designed to track the code and associated analysis. It also supports comparing models, testing model code, deploying models to a production system, and monitoring the performance of the models. Model Manager has always been able to perform these tasks for SAS models. But since many data scientists now incorporate Python and R into their data analysis projects, Model Manager now also handles these models as first-class models. This means that open source models can be registered, tested, compared, deployed, and monitored either on their own or alongside SAS models. To help support the open source modeler, we provide a GitHub site that provides a variety of resources. On this site, we provide a set of sample models in Python and R, scripts to perform common API tasks, and a Python library that I'll show more examples from later for registering and using Python models in Model Manager. Also, to better support open source modelers, we recently released our first version of OpenModel Manager. OpenModel Manager is a standalone deployment of SAS Model Manager and encapsulates data management, model testing, and model performance management into a single Docker container that is easily deployed without needing a full IT department. It provides significant enhancements to improve the import, testing, and publishing of Python and R models. At the same time, it also supports most SAS models. When publishing a model, Model Manager makes it easy to create model containers that allow you to execute your model in any Docker or Kubernetes environment, including direct integration with AWS and Azure. This approach works great with many DevOps pipeline tools such as Jenkins and GitLab CI/CD. While OpenModel Manager is great for managing models, it is not integrated with the rest of the SAS solutions such as Model Studio or Visual Analytics. But all of the features that have been added to OpenModel Manager will also become part of the full version of Model Manager starting in VIA 4.01. Model Manager has a comprehensive REST API that covers all of the functionality that can be performed through the Model Manager UI. The APIs referenced in the links on this slide cover all the functionality described in this presentation. And as mentioned earlier, we have also created a Python library that provides high-level calls that are good for working with Python models. Within Model Manager, the first key area of the model lifecycle is model registration. Using tools like scikit-learn and TensorFlow, modelers are increasingly using machine learning to discover models from their data. Our Python library, named PZMM, provides methods to read the machine learning models and extract useful analytic data. The processing captures metadata that is important to model analysts, including the input and output variables, fit statistics, and lift and rock charts. At the same time, code is generated for executing the packaged model, both inside of Model Manager and in production deployments. PZMM then packages the model and registers it with Model Manager for the next steps of the life cycle. The PZMM package provides an easy way to take a model, such as a scikit-learn decision tree, and generate Python code that Model Manager then uses to manage, test, and deploy the model. The PZMM program on the left takes as input a reference to a model, commonly in a pickle file, some information about the input and output columns, a reference to the training data set, and some information about what to call the model and where to store temporary information. The write score code function generates the program on the right, which is a simple program that loads the model from its pickle file and also provides some calculated values for missing data values and adds additional code that is important for Model Manager. The items that Model Manager requires to properly manage the model are quite simple but easy to overlook. First, import the settings package. This is a simple package that defines global variables associated with the model. Second, define the score method with all the input columns as parameters. This, as is very obvious, allows Model Manager to map the input data into the model. Third, declare the output columns as a docstring, starting with the word output. The order of the variables in the docstring should match the order that the output variables are returned in the return statement at the bottom. As you can see, this program returns two outputs, a probability and a classification. These will be mapped to the columns EM event probability and EM classification in the output data set. And fourth, specify the path of your pickle file using a variable defined in the imported settings package, pickle path. Since Model Manager can deploy the model to multiple locations, using settings.picklepath allows for dynamic deployment without needing to rewrite the source code. As mentioned earlier, in addition to generating source code, PZMM also analyzes the model's training data to generate important training analysis for the model, such as fit statistics and lift and rock charts. Once the score code and training analysis are completed, PZMM packages the model and imports it into Model Manager. Once in Model Manager, all of the information about the model is available to review. The generated code can be edited for further customization. You can also view and edit the variables and other model metadata. For any complex task, you will likely want to create multiple models using different training parameters or algorithms so that you can find the one that best solves your problem. Model Manager manages models and projects so that they can be analyzed together. This provides input for selecting the champion model to put into your production system. One of the key features of Model Manager is its model comparison. This lets a user compare multiple models to view the training analysis side by side. Here we have selected a Python decision tree model to compare with an R model using logistic regression. Here we see the comparison of the models, showing the input variables used by the models and a variety of fit statistics and charts. Model Manager allows comparison of multiple models at one time. So you could have 3 or 4 models here as well. While the model code was likely tested when it was generated, it is prudent to also test it against more production-like data. The testing interface allows for specifying multiple tests against different models and data sets. This example shows that the model failed the test. Model Manager provides a full runtime log of execution to help with analyzing problems. While pre-deployment testing occurs in a sandbox environment, Model Manager also provides validation in the actual deployed environment. Publishing validation works the same as score testing, but runs where the model was deployed, such as in SAS's CAS or microanalytics server, or in a standalone container in AWS or Azure. Once the best model has been selected and validated, you will want to deploy it to a production system. The publishing component allows for deploying multiple models at one time. As mentioned, models are deployable to a variety of locations. For open source models, model containers are popular and can be deployed to AWS, Azure, or a private Docker registry. Containerized deployment is a good way to get your models into your analytics pipeline. Model containers are standalone runtime environments for a model. Basically, Model Manager produces a Docker container with a Python or R environment suitable for running the model code. Model containers provide a simple web service to pass in CSV data and retrieve the results. The container's web service API is documented on the Github site referenced above. Here is a simple Python program showing execution for a single row of data. The web service call can take many rows at one time. The amount of data is only limited by the amount of memory allocated to the container. The Python program reads the input data from a CSV file, which is passed to the executions endpoint. No specifics of the model are needed for running the model. Results are retrieved using the query endpoint, and run logs are available by using the log endpoint. Once the model is running in production, you will want to monitor the model's performance to assure that it is providing the information that you hope for. Model monitoring is a complicated but very important process in the design. Model monitoring is a complicated but very important process. In the diagrammed process, the production model scores the data as it is entered into the system, and the scored data is then maintained until a process outcome occurs. The process outcome could be on-time or late loan payments in a banking system, or mechanical failures in a manufacturing system. But once the outcome is known, the data is fed back to Model Manager so that the monitoring process can analyze how the deployed model is performing. The model monitoring process produces a set of output charts that give a data analyst an overview of the model's performance. The charts show the performance of the model over multiple time frames, In a banking system, this may be quarters, but in a manufacturing system, this may be days, or even parts of days. Monitoring allows the data analyst to see when the model has decayed and needs to be replaced, at which point another model life cycle is started. Thank you for watching, and please send any comments to the email address on the screen.